Assalamu alaikum everyone. In today's lecture we are going to discuss about the classification of TGA curve. First of all, look into this curve, which is A curve. In the y-axis, again I repeat that in y-axis we have a change in mass, in x-axis we have a temperature increase from left to right. In curve A we are seeing that it is a straight line. There is no increase, a change in mass in this curve. Practically this curve indicate that there is no change in mass over entire range of temperature. From this temperature range to this, there is no change in mass in this temperature range, and we can also conclude that A is stable in this temperature. If we look into the curve B, in the initial position here we are seeing there is a drop in there is a decrease in mass of the sample, and after that there is a stability of curve A. This change in mass is desorption of something or drying of some substance, because the temperature we are seeing here is around 100 degrees Celsius, and this could be the drying process of the sample is large, followed by mass plateau. After that there is huge decrease loss of mass, and then there is a constant curve which indicate that from this temperature to up till this there is stability. Moving on, in curve C we are seeing that from room temperature to this temperature we have a stable substance, and after that there is a very sharp decrease in mass, and then it is again the new product is stable. This single step indicate that this is a single stage decomposition of the initial. Here if we have a substance A or sample A at this position, after this decomposition we obtain a curve, a new substance, a new material, which is B, and B is stable into a higher temperature range. If you look into the curve D, there is a multi step, and each step indicate that there is a decomposition of this substance, and after each decomposition we are obtaining a new product, a new material. These multi-step indicate that there is a multi-step decomposition, and after first decomposition we obtain, let's suppose if initially we have a substance A, after first decomposition we obtain a new material which is a B. After second decomposition, this one we obtain a material C, and in every step we are decreasing with mass and simultaneously with the production or with the synthesis of a completely new substance, and after this step we are obtaining a new substance, a new material, which is D, and it is stable up to this temperature. If we see into the curve E, this is similar to D, but it is due to faster heating rates, or due to no intermediate phases, or intermediate phases are not stable as in the above one. So this could be mainly we can say that this is higher heating rate could be the main reason of this type of curve, multi-stage decomposition. In curve F we are seeing the completely different phenomena, completely different process, where we are increasing with the mass of the substance. And why in TGA when we are seeing the increase in mass, this is mainly due to the surface oxidation of the sample, and here we are seeing that this is an atmospheric reaction, and this increase in mass is due to surface oxidation. In G curve, this G is similar to F. G is similar to F, but initially we are increasing with mass. After this point, we are decreasing with the mass, or a new product is formed, and after crossing this temperature, this new product is not stable, and it decomposed off and form a completely new material, and decreasing with the mass. Now we will discuss about a case study of calcium oxalate decomposition, how the calcium oxalate decomposition occurred in TGA machine while we heat this material. In the first step, that this calcium oxalate decomposed into calcium oxalate monohydrate transform into calcium oxalate and water is evaporated. In the second step, this calcium oxalate changes into calcium borate and carbon monoxide is also produced carbon monoxide and calcium oxide. So by removing this calcium monoxide with the carrier gas, we are actually decreasing the mass of the substance. So in TGA curve, we are seeing this kind of result. Here we have a calcium oxalate, hydrated calcium oxalate. As we increase the temperature and about 100 degrees Celsius temperature, the water is evaporated, about 12.57% water, which have a mass of 0.8753 milligram will be evaporated, and this mass decreases to this point. After that, calcium oxalate is formed, which is the here water is removed, and then calcium oxalate is present in this stage. In this step, from this point to up till this point, calcium oxalate is stable, and then calcium oxalate is decomposed off, and carbon monoxide is evaporated. So the weight of the carbon monoxide is 1.355 milligram, and this is about 19.47% of the total weight. After that, a new product, which is calcium carbonate, is formed, and from this temperature to this temperature, in calcium carbonate is stable, and when we cross that about 600 degrees Celsius temperature, this calcium carbonate changes into calcium oxide and carbon monoxide is releases. So after this, calcium oxide is stable up till 900 or you can say that 1000 degrees Celsius temperature, and the carbon monoxide is the byproduct. Carbon oxide and water is evaporated, and these are removed. These three components are the main reasons why the mass of the our initial sample is decreases. So you can say that if we have 100 milligram of initial weight of the sample, after passing through this multi-stage decomposition, finally we are left with about 40 milligram of the sample. In the coming lecture, we are going to discuss about the thermal degradation profile of common polymers. Thank you so much.